So you know the one parameter model is very simple and it's not realistic because we talk about transition and transversion. Empirically, we observe different transition and transversion rate. And at the chemical level, we look at the molecule. And you know the purine and pyrimidine, they are not mutated at equal rate to each other. So based on those observations, we know we have to modify the model from one parameter to additional. For example, the second model we are going to talk about is the two-parameter model. So the two-parameter model is just one additional parameter, beta. Remember the diagram we showed in the beginning of this chapter as the one-parameter model? So everything is alpha. Now it's just changed. We put A and G in one group, C and T in another group. So based on the chemical property that we already learned from our biology class. So AG, the change between A and G or between C and T, that's called alpha. But anything between the two groups become beta. So we have two parameters here. Basically, they reflect the transition and transversion we talked about in the beginning of this class. So now we have two models, but the same practice as we used in the previous model. The only thing we concern is how the nucleotide will change over time. So remember the probability for a given one unique time in the one parameter model is 1 minus 3 alpha because there are 3 different status and everything is alpha. Similarly here, for A change to G, T, or C, now it's in a different probability, right? So change it to G is alpha, but change to C or T is beta. So that's showing in the formula here. So the probability stay as an A, stay unchanged. It's 1 minus alpha, that's to G, beta minus beta to T, minus beta to C. So that's the same thing. We just change 3 alpha to alpha and to beta because there's alpha probability change to G, beta probability change to C, and beta probability change to T. So that's 1 minus 1 alpha and 2 beta. So that's the probability given one-time units, the nucleotide stay with A status. So that's the same thing. And if you understand that, it will be very easy for the following slides. So the following slides just put transition and transversion on this slide. It looks complicated because from the 2 possible process, now you have 4 different possible processes. But for each individual one, it's the same practice as the previous slide. So as we did for the one parameter model, now at the time equals to 2. And you want to know what is the status based on the previous t equal to 1. And that's the same thing as we did. Then you only consider if it's a transition, it's alpha. If it's transversion, then that's beta. And that's the formula showing at the bottom. So just try to show you what exactly people written in the literature. And this is also on your handout and note and the book. It's just like a different ways to express that. And also, in addition to talk about A, the possibility of A, we can talk about the other 3 possibilities. So it's either C or T or G. So that was like a list here. And at the end, you want to know what's the probability the 2 sequences still stay at an A status. And that's the formula in the bottom. And the differences here is There are two parameters. They are alpha and the beta. But the approximation or the calculation we did is very similar. So you start with the sequence status and change over time, and you ask how we can estimate the nucleotide change during the historical time. So that's the thing we want to illustrate here. So if we set another parameter, y, or just like talk about another probability. And actually we are talking about if the change, the probability that initial nucleotide and the end nucleotide is different. So that's try to show in here. So that's like they change from one particular nucleotide to the other nucleotide, and what's the probability for this calculation. And showing here is try to illustrate the probability could be like all this, like A to G, G to A, or T to C, C to Z, if we concerning about all the transitions. And of course, similarly, you can focus on the transversions. So there are only two different types. It's either a transition or a transversion. So what you are observation is the differences between the two sequences. And this is the formula for transversion. Then you also can talk about what's the probability they stay the same. So there's only three. So they change, it's a transition change or the transversion change, or there's no change at all. And the three added together, and of course they are two different probability. There are two types of transversion and one type of transition. So they add up together should equal to 1. So that's the overall, the sum of all the probability, as I mentioned, at like when we deal with the frequency in the population.